Fine. So far we have seen what is meant by contiguous allocation, right? What is meant by contiguous allocation? In contiguous allocation, you take any process, the address space of that process should be in contiguous addresses of our main memory. Okay. If this is true for all processes, then we say that as contiguous allocation. Fine. Now contiguous allocation are of two types. One is fixed partitioning, and another one is variable partitioning. Okay. Fixed partitioning is also called as static partitioning, whereas variable partitioning is also called as dynamic partitioning. Let's see first about what is meant by fixed partitioning. Okay. See, fixed partitioning is very simple. Okay. Let us assume this is our RAM. Okay. Now what we will be doing is, see, as of now, let us assume the RAM is empty. Okay. Before starting off our computer, let us assume RAM is empty, which it doesn't have any processes. What they will do is, they will partition the RAM into some partitions. Okay, each one of them is called as a partition. Let us assume here we have 4 partitions, right? Here the RAM has been divided into 4 partitions. Let us assume that its size is 2 MB, its size is say 1 MB, its size is again 1 MB, its size is, let us assume, 3 MB. Okay, this is how the RAM has been partitioned. See, there will, of course the RAM size will be much bigger, right? This is very small, 3 plus 5 plus 7, it is just 7 MB. Actually the size of RAM will be roughly around 4 GB, right? Just I wanted to explain fixed partitioning, that's why I'm taking very simple example. Okay, so what we will be doing is, before placing any process into the RAM, we will be dividing our RAM into some fixed size partition. Why are they using the word fixed here? Because these partition sizes will remain fixed, they will never change. For example, first partition will always have 2 MB, second partition will always have 1 MB, irrespective of our size of our process. Okay, so whatever be the size of our process, throughout always our computer's RAM will have, this is how our computer's RAM will be partitioned into. Okay, fine. Now this has a lot of disadvantages, right? Of course, nowhere it is used right now. It was used long back, but now nobody is using it. Okay, let's see what are the disadvantages of this fixed partitioning. Okay, first problem is, there is something called as internal fragmentation. Okay, internal fragmentation problem exists. What is meant by internal fragmentation is, see, let us assume this is how RAM has been partitioned. Okay, initially before placing any process, our RAM has been partitioned it in this way. Fine. Now let us assume this is our hard disk, right? From hard disk we move processes into RAM, right? Let us assume there is a process named as P1 which is coming into the RAM, which wants to come into the RAM, and let us assume its size is say 0.5 MB. Okay, it is just 0.5 MB, 0.5 MB. Now all this is 2 MB, all these are in MBs. Okay, megabytes. Now how will I place this 0.5 MB process over here? I can choose any partition, right? I can choose this partition or whatever it is. Let us assume I'm choosing this 1 MB partition. Okay, this partition. Now I'm placing this 0.5 MB process over here. Okay, this is P1. Sorry, this is P1, right? P1 has been placed here. Now this 0.5 MB is as of now free, right? Now can I place some other process over here? No, I cannot do that. Why I cannot do that? See, the rules of fixed partitioning is, once the RAM will be divided into fixed partitions. Once partitioning is being done, always every partition can hold only one process. Okay, every partition can hold only one process irrespective of the size of a process. Okay, so we cannot place more than one. For example, here we cannot place one more process, say P2 over here, because some process P1 is already residing in this partition, and so no other process can be placed over here. See, two important rules about fixed partitioning is, let's see the two important rules. Okay, the two important rules which we need to follow in case of fixed partitioning. See, no more than one process cannot share a single partition, which means a partition cannot hold more than one process data. Okay, which means a process can hold only one process data. Similarly, we have one more point. Sorry, this is not process. Okay, this is partition. A partition can hold only one process data, right? which means in this partition I can either place process P1 or P2 or P3 or any one of those, but I cannot place both P1 and P2 because our partition can hold only one process. Fine. Similarly, a process cannot span across more than one partition. Okay, a process can be placed in only one partition and it cannot span across two or more partitions. Okay, two or more partitions. What does it mean is, see, in case let us assume our process size is 5 MB. Now, can I place 2 MB over here and 3 MB over here? That is not allowed in case of fixed partitioning. Okay, that is not allowed. Which means, in simple terms, I can say that if our RAM will be divided into fixed size partitions and every partition can hold exactly one process, and so the degree of multiprogramming, which means the number of processes which can be placed in our RAM, is equal to the number of partitions. Okay, see here we have 4 partitions and so there can be only 4 processes. Okay, so that is one more disadvantage. See, we didn't see about internal fragmentation till, right? Now let's come to this. Initially our partition is of size 1 MB. Now a process P1 whose size is 0.5 MB has to be placed inside the RAM. We can place it in any partition, that is fine. Let us assume we have decided that we are going to place it in this 1 MB, okay, this partition. Now what will happen is we will place the 0.5 MB over here. The remaining 0.5 is free, right? They are not occupied right now. Now can I place some other process over here? I cannot place it because a partition can hold only one process. So there is no other way other than wasting this space, which means as long as process P1 is present inside this partition, this space cannot be used for any other partition. Okay, so actually we are not utilizing the space, right? We are actually wasting the space. See, once P1 is completed, it will actually be removed from the RAM, and so our partition will be free, and so we can allocate some other process. That is fine. But as long as process P1 is over here, this space will be free without being utilized. Okay, that is actually a disadvantage, right? We wanted to make use of our computer's resources as much as possible. So this problem is also called as internal fragmentation problem. Internal fragmentation is nothing but, in fixed partitioning, size of process may be less than the size of a partition, and so some space within the partition has to be wasted without being utilized. Okay, that is what we mean by internal fragmentation, and clearly our fixed partitioning suffers from internal fragmentation problem. Okay, it is very evident, right? Because we don't have a partition of size 0.5 MB, so there is no other way other than placing the process in the bigger partition, and so some space is getting wasted. Okay, fine. Now let's see the next disadvantage. Process size is limited by the size of the largest partition. Okay, it is very simple. See, as of now we have 4 partitions. Okay, 2 MB, 1 MB, 1 MB and 3 MB. Now what can be the maximum size of a process I can place over here? Only 3 MB, right? I cannot place a process more than 3 MB. Why? See, can I place 4 MB process, 3 MB over here and 1 MB over here? That is not allowed, right? Why? Because a process cannot span across more than one partition, right? So the maximum size a process can be present in such kind of computers is just 3 MB, and that is actually a disadvantage. Okay, so one thing I can say is process size is limited by the size of the largest partition, and the largest partition here is 3 MB. Okay, fine. Degree of multiprogramming is limited by the number of partitions. So in case if I have 4 partitions, then I can hold only 4 processes. It is very obvious, right? Because we have divided the RAM into partitions, and we said that every partition can hold exactly one process. So in case if we have 4 partitions, then we can hold only 4 processes. So that is another disadvantage. See, all these disadvantages you will not find in case of variable partitioning. Okay, once we see variable partitioning, it will be even more clear for you. One important point you need to write down is there is no external fragmentation problem in fixed partitioning. Okay, we will see what is meant by external fragmentation while discussing about variable partitioning. At that point it will be very clear. Okay, because variable partitioning suffers from external fragmentation, whereas a fixed partitioning doesn't suffer from external fragmentation. Okay, so while discussing about variable partitioning, we will see first what is meant by external fragmentation, and then we will see why it happens in variable partitioning but it doesn't happen in fixed partitioning. Okay, fine.